Hi guys. Okay, so we really need to go over reversibility, equilibrium, and Le Chatelier's principle some more. So here we go. Let's look at the screen. This is the forward reaction. This is the reverse. Let's label. In blue, I'm going to label. These are my reactants over here. And over here would be my products. Oh, there we go. And this is for the forward. And so my forward is going to be blue. Let's just look in the forward direction. Here are my reactants, 45 kJ. Products, right down here, 10. Oh, sorry, jumped ahead. Sure we can see. Heat of reaction is the difference. So I'm going to get my writing tool here. Is right here. Oh, sorry. And here. And usually I just like drawing that triangle, right? That difference between the products and reactants. It's always products minus reactants, final minus initial. Okay, kind of backwards. So in this case, it would be 10 minus the 45, right? 10 minus 45, negative 35 overall. Okay, overall, you can see this is going downward. That makes it exothermic. And that makes sense because this is negative. Always double check yourself. Activation energy is from the reactants up to the activated complex. And again, we always go backwards. So it's 103 minus 45. So 103 minus 45, that gives me 58 kJ. And that's all in the forward. And again, just make sure you can see that top piece there. Okay, now let's go in reverse. Let's use green. Now I'm going backwards. Here. Sorry, let me grab that. There we go. Nope, that's not that one. Okay, so we're going to make this green. Reactants. Now over here, these will be my products. Oh, no. Technical difficulties. There we go. We're going backwards. And again, I'm going to make that all in green, my reverse. So I'm now, or you can redraw it. If I have students that redraw it backwards, like a mirror image, or you can just think backwards. So now my reactants are here because I'm going in reverse. So 10. My reactants, my products are now 45, right? Because they're going backwards. My heat of reaction will be now 45, right? Because now we're talking about my products. We're going green minus reactants. And it'll be positive 35, which makes sense because get rid of some of these lines here. Okay. If I'm looking in the backwards direction, you can see it's going all overall upwards. Does that make sense? That's positive because it's going to be endothermic. Okay. So again, we're going backwards. Reverse means to go backwards. Activation energy. These are my reactants here now, 10. And the top of the hill is still 103. Let's do our math. So 103, my activated complex, this time minus 10, because those are my reactants now. And that gives us 93. Okay. So I hope that gives you a better sense of that. There's a lot of practice on YouTube you can do for this. Okay, let's move on. Okay, so we have a delta H, right, often written as a triangle, but here they're using the capital D to mean delta, and it's positive. That means it's endothermic. That means the heat is going to be over on the reactant side. So these are my reactants. These are my products for the forward reaction. And we're going to talk about how it's going to shift. Always start with how it shifts right or left, and everything else will fall into place. Okay. So I'm put a star there maybe. Here we go. So N2O4 is increased. If I'm increasing this side, it's like this side is going to tilt down. So I'm going to have to shift right to make that balance out. It's going to shift right. Now, if it shifts right, let's go ahead and draw that arrow up here. Okay. Everything on this side, right, this is where it came from. If it's shifting right, this is all going to decrease. And over here, this will increase. It's shifting this direction. This side will increase. Where you came from decreases, where you're going increases. So they're asking about the NO2. And looking at it, it's going to increase. X means we don't need to comment on that because that's the stressor. Right? So take a minute, make sure you understand it. Once you know the shift direction, draw that arrow, and then you'll be able to see what increases and decreases. Also, it's shifting to the right. That is the forward direction, favoring the forward reaction. Right? To the right, forward. Okay, so now let's go on to number 2. Here, let's make this in blue. NO2 is increased. NO2 is over here on the right side. If I increase it, how is that going to tip the scales? Well, it's going to make this side go down, right? I'm adding more. I'm increasing the weight, so to speak. And if I do that, now it's going to have to shift left to push it back down. Okay, so it's going to shift left. Now let's draw that arrow. Okay, it's shifting left. Okay. And they're asking, what's going to happen to the N2O4? They're asking you to look at something specific here, just the N2O4. Well, where you came from decreases. Where you're going, right, where the arrow points, that's going to increase. And if you're going left, it's favoring the reverse reaction. And let's try one more together. Temperature is increased. Temperature's over here. Temperature's acting like a reactant. Let's get rid of the arrow for now. So temperature's on this side, the left side, heat, temperature are related. So how is that going to tip the scales? Go back to orange here. Well, if it's on the left side and you're adding it, it's going to push that side down. It's going to be tilted this way, which means it's going to shift right to make it go back to equilibrium. Let's draw that arrow. We know it's shifting in that direction. This time we have to comment on both. Okay, so let's take a look. Where it came from, right? This is the direction it's going. Where it came from decreases. So N2O4 is going to decrease. And where it's going, NO2, is going to increase. And of course, you can see that it's going to the right. That's favoring the forward reaction. Okay, take a second, pause the video if you need to, go through and see if you can figure out this one on your own. Remember, decreased is like removing weight. Hopefully you've paused the video and thought for yourself. If not, pause now, because I'm going to go over the answer. Again, the more you just listen and passively take in my answers, the less that you are critically thinking. Okay. So N2O4 is on the left side of the equation, and we're removing it. Right? That's going to make that side lighter and tip up. Right? It's like removing that kid from the balance, the seesaw. So how am I going to make it go back down to equilibrium? I'm going to have to shift to the left. Okay. Again, this time, let's draw the arrow. Always drawing the arrows helps. Shifting left, draw that arrow to the left. This time, they just want us to comment on NO2. Again, where are you coming from? That's going to decrease. Okay. So again, once you draw the arrow, you know what decreases, you know what increases. And then you just answer the question that's been asked. Right? Don't give extra information. The lights go out here sometimes and sensors. And of course, if you're going to the left, look, that is literally the reverse reaction being favored. Okay. Pressure works a little bit differently. Pressure is more about the moles of gas. So let's take a look at that. I have a gas here. I have 1 mole. When there's no number, 1 is implied. 1 mole of gas. And on this side, this is a gas, so I have 2 moles of gas. I have 2 moles because of the coefficient. Okay, so pressure will have an effect because the moles of gas are unequal. If pressure is increased, you have a lot of collisions going on. To make it go back to equilibrium, you want less collisions. So it's going to favor, it's going to favor the direction that has less moles of gas. Less moles of gas will reduce that pressure and send you back to equilibrium. So you can see the direction that has less moles of gas is to the left. Again, make sure we're looking in the right place. Once I know that it's shifting left, again, look at the arrow. Okay. Where you're coming from, the NO2 decreases. And where the arrow is going, over here, N2O4, that side's always going to increase. If you're going to the left, that is clearly the reverse. Okay, let's try these last couple again. Make sure you're pausing the video and trying it for yourself. NO2 is decreased. Okay, so let's erase our work here so we can get to the next one. Delete. Oh. Okay. And okay, so back to number 6 here. NO2 is decreased. What side is NO2 on? It's on the right side. Decreased is like a removing weight. So how is that scale going to tip? Let's go draw it. Right? Initially, it starts off equal, but if you're removing this side, a kid getting off the seesaw, that side's going to tip up. There's less weight there to push it down, so it's going to tip up. And how do you get back to equilibrium? The shift to the right. You have to push it down to the right. Okay. So let's draw that arrow to the right. And once I have the arrow, right, where it came from decreases, where it's going increases, right? This is a direction. So this side decreases. And that's what they're asking us to focus on. Going to the right is the forward. So hopefully you're getting the pattern better now. If not, rewatch. Okay. So let's get rid of that work. We're going to go on to the last one here. Temperature is decreased. Temperature is heat. Which side is that on? That's on the left side over here. Again, make sure you're following the cursor. And removing it, how is that going to change the balance? You're removing it. That's going to make that side go up. It's going to tip upwards, right? There's less there. So temperature is decreased. It tips up on that side. You're going to have to push to the left to make that side go down. Let's draw that arrow, and that's going to tell us the next step. Right? NO2, where it's right, that's where it's coming from. This is where it's going. Where it's coming from decreases. And N2O4 is where it's going. Right? That's where the arrow is. So that's going to increase. And you can see this is clearly going in reverse. We're going to do another practice. Okay, there we go. Okay, so let's take a look at some more practice problems because clearly a lot of you guys were struggling or guessing or gave up and left the blank. Okay. So in this worksheet, we're going to look at specific questions, not really a chart. Okay, so let's go through. Which way would the equilibrium shift? To the right or to the left? That's what they're asking us to write. Okay. So let's take a look. Here's our reaction. We have the left side and the right side. Okay. Let's see if I can go back. So I want to be able to write on this. There we go. Hit right. Okay, now we can write on it. Great. Okay, so again, let's just mark. Right, this is the left side, and the arrow separates it from the right side. So just to be really clear. Okay, maybe that's part of the confusion. I'm not sure. Okay, we're decreasing the concentration of dihydrogen sulfide. Well, dihydrogen sulfide, H2 dihydrogen sulfide. So right here, it's on the left side. And by decreasing it, right? So again, remember you're starting off equal. And if dihydrogen, let's see if I can do this back right here we go. So dihydrogen sulfide is on the left side here. And you're decreasing it. That's like removing weight. How's that make it going to look? It's going to make it tip up. Right? It was flat, but that kid got off of that side. And if there's less weight, that side's going to tip upwards. So you can see we're going to have to push to the left to make that go back to equilibrium. So that's how you need to think it through. There's no other trick. You can't memorize it's always to the left, it's always to the, it doesn't work that way. You have to be able to logically think it through. Okay. Increasing pressure on the system isn't about tipping the scales, it's about the moles. So let's add up the moles of gas. Okay, so here, there's a 1 implied there, and we have a 2 here, right? That's a 2. So, and they're both gases. So I have a total on this side of 3 moles of gas. So if I can drag that down. Okay, it's not letting me. So 3 moles of gas on this side. Over here, these are both gases. I have 1 mole here and 4 moles here. So on the right side, I have a total of 5 moles of gas. So 3, 1 and 2 makes the 3 moles. And here 1 and 4 made the 5 moles. Again, we talk about sides. Increasing the pressure, you want less moles. You want the equilibrium to go back. So by increasing the pressure, you increase collisions. What's going to undo that? less stuff, right? So it's going to shift. Oh, sorry. You go grab there. It's going to shift. Sorry. There we go. It's going to shift to the left from more to less. Right? So increasing the pressure, you want less moles. That'll lessen that pressure. Okay, so it's going to shift left. Okay, let's get rid of some of this. Clean up the area and get ready for our next problem. Okay, and let's see if it'll let me clean that. There we go. Okay, so let's clean some of this area up. And we're going to go on to C, increasing the temperature. Okay, well, in this one, we don't see any, it doesn't say if it's endo or exothermic. So we don't know if this is going to shift it either way. Okay. However, this does look like it's methane. Okay. So let's say heat would be released. That means heat's on this side. Normally, they would give you a number or tell you which side. Increasing the temperature, if it's over on this side here, is going to make that side tip down, right? It's going to be heavy on that side. So increasing the temperature, which is on the right side, will make the right side tip downwards. Right? Remember, it starts off flat. This side is getting pushed down. So how am I going to undo that? Well, I have to push backwards, push to the left. Next, increasing the concentration of carbon disulfide. First, you have to find out where that is. Carbon right here, 2 sulfide. It's right here. It's on the right side. And now I'm increasing it. I'm increasing this. So again, what's that going to do? It's like adding weight to that side. If I add weight to that side's going to go downwards. Again, I'm going to have to shift left to undo that. Okay, next, decrease the concentration of methane. Methane is over here on the left. Decreasing is like removing weight. Okay, so if I'm decreasing or removing weight from this side, what's going to happen? Let's get a different color. It's going to tip up, right? It's like a kid getting off that side. So again, it's going to shift left. So if you were looking for some sort of left, right, left pattern, that's not going to always work. If you're thinking increase is always left or decrease is always right, that's not going to work either. You really do have to think it through. Okay, let me get the lights back on. Oh, there we go. Okay, so again, just to be, I'm trying to be as clear as I can. Okay, if I'm adding weight, let's say to this side, it gets pushed down, and I'm going to shift. Okay. If I'm removing weight, whoop, right, and then I'm going to shift. What about the other side? Adding weight, increasing, or decreasing. Okay? You have to go through the steps. There's no shortcuts. Okay, so let's continue. Okay, sulfur dioxide is added to the system. First, where is it? What side is it on? SO2, sulfur dioxide. You need to know the names of things. We did learn names. And we're adding it. That means that this right side is going to get pushed down. Adding something is like adding weight to that side or pushing it down. Okay, so it's going to look like that. And then how do you undo that? Well, you're going to have to shift to the left. Sulfur trioxide is removed from the system. Sulfur trioxide is here on the left. Removing it is like having less weight there. How's that going to change the balance? I'm removing something from that side. How's the scale going to tip? Well, if I'm removing something from that side's going to pop up. It's going to be lighter. And again, you're shifting to the left. Oxygen is added to the system. Where is it? It's over here on the right. Adding it is like adding weight to that side. How is that going to look as far as the balance goes? Well, if I'm adding it to the right side, again, this is my balance, right? Think of it as a balance. This is the side I'm adding weight to. It's going to tip that side down. How are you going to shift to push it back to equilibrium, to balance, to flat? Well, you're going to shift left. Okay. Let's go. Keep going. We need the practice. HGO is added to the system. Here's HGO. We're adding that weight to that side. It's on the left. How's that going to look? Again, you should be using your pen or pencil. I'm adding weight to that side. That side's going to be pushed down. How do I go back to being flat? I have to shift to the right. I have to push that side down. Now, I'm shifting to the right. Let's go the next step. Oh, sorry. Let me get my... So let's draw that arrow. Here, let me draw that a little bit better. There we go. Drawing this arrow. Boom. Shifting to the right. So maybe you're getting the whole tilting mixed up with the shifting of the arrows. Maybe that's it. Figure out, if you're struggling still, where you're going wrong. And then I'll be able to help more clearly. Okay. So once you know you're shifting to the right, draw this arrow that you're shifting that way. And that's going to tell you what's increasing and decreasing. Okay. Well, HGO is already added to the system, so we're not going to comment on that. That's already been talked about. Okay. What's going to happen to the HG and the O2? Well, that's where things are heading. If more things are heading there, this side's the side that's going to increase. So the HG and O2 will increase in concentration. And so make sure you're making the connection now. And let's erase the arrow and go on to the next one. Pressure. Remember, pressure is only about gases, not about tilting up and down. So let's figure out how many moles of gas are on each side. Well, this is a solid. That's the only thing on that side. So I have 0 moles of gas on this left side. And on the, over here, on the right side, that's a liquid. Hg is L, a liquid, no. And O2 gas. I have 1 mole of O2, right? One's implied, 1 mole of gas. So it will be affected by the pressure if you have an uneven amount. Pressure is increasing. Again, if you have an increase in pressure, how are you going to undo that? Less collisions. What's going to give you less collisions? Less gas. Okay, so let's draw the arrow. Less is going to be shifting to the left in this case, where there's less gas. Now, let's continue. If it's shifting to the left, what's going to happen to all of these? Okay, so let's go through. Well, the Hg and O2, that's where you're coming from. Those are going to go down. Hg and O2 will decrease. And where is that stuff going? Oh, it's going over here to the left. So the HGO will increase. So I move this over so you guys can see that a little clearer. There we go. There. Okay, make sure you're thinking things through. Okay, so when the pressure of the mixture of gases is decrease, what will be the effect on the equilibrium position? Okay. So let's add up the moles of gas. Pressure's only about adding up gas. This is a gas. This is a gas. I have 4 plus 1 more here that's implied. So on this side, I have 5 moles of gas. And then on the other side, this is a gas. So that's 2 moles right here, 2. And then 2 more, so that's 4 moles of gas. 4 moles of gas. Move that up. There we go. Again, the arrows tell us where, the sides are. The left side, the right side. If I'm decreasing pressure, well, how do I get back to more pressure? Right? If I decrease it, I want to go back. So now I need to shift to more moles. Decreasing pressure will shift to more moles. So let's draw the arrow. Where are there more moles? Well, over here. So I'm going to draw my arrow. Oh, let's grab that. It's going to shift to the left, right? From less to more, because you want to undo this decrease in pressure. So that's to the left. Okay, let's go through. I'm going to do these a little more quickly, so hopefully you're picking up. Increasing pressure in general, you're going to shift to less moles of gas. So let's make a note of that. Increasing pressure, you shift to less moles gas. Let's go find that. I have 2 moles of gas here and 1 more. So 3, and over here, 2 and 2 make 4. So I want less moles. I'm going to shift to the left. Okay. B, this is a solid. That doesn't count. So I only have 4 moles of gas here. Now on this side, I have 2 plus the 1, 3 moles. Again, if we're increasing pressure, we're going to always go in the direction of less moles. So from 4 to 3, that's shifting to the right. Next, again, we only care about gases when we're dealing with pressure. This is a gas. I have 1 mole. This is a gas here, H2. I have 1 mole. That's 2 moles of gas on the left side. Right? I have a little room. I can write that 2 moles of gas. Now let's go to the other side. This is a solid. That doesn't count. So they're not affected by pressure. But I do have this 1 mole of water gas. So 1 mole of gas. And again, increasing pressure will always shift to the least amount of gas. So it's going to shift in this direction to the right. Again, this is something you can't memorize. This is something you can't just do in your head. You need to visualize it. Last, temperature. Temperature is connected to energy, and treat it, right? In this case, going back to our teeter-totter. Energy is here on the right. If energy is on the right and I'm decreasing it, removing it. Removing doesn't mean pushing down. Removing is the opposite. Less weight. So let's draw what that would visually look like, right? This is my balance or tipping point. And if this is being removed, it's going to tip upwards. How are you going to fix that and make it go back to equilibrium? You're going to shift to the right. Now let's take it a step further. If I'm shifting to the right, everything on this side, where you're coming from, decreases. So the H2 and Cl2 will decrease. And wherever it's going, the HCl will increase. Okay, see if I can move these over and then it's a little easier to read. There we go. Okay, let's go on to the next one. Now heat is here on the left. Again, be on following where my cursor is on the screen. Heat is here, so let's use a different color here. This again, the arrows always represent our tipping point, where our scale is. It always starts off flat, but now we're decreasing the temperature. We're removing something from this side That's going to make that side pop upwards. How are you going to make it go back? You're going to have to push to the left. Shift left. Okay. Now that we know we're shifting left, all right, we can even, so everything on this side, again, let's draw a nice big arrow. Maybe that'll help make things clearer for you guys. It's going to shift all the way to the left, right? So where you're coming from decreases. So find out where that starts. N2 and H2 will decrease. And where you're going, the NH3 will increase. Okay. And last one here. Again, we're only looking at temperature, so where's the heat? Heat's here on the right. We're decreasing it. Okay, again, sorry. We're decreasing it. Here's the heat. So we're going to have to make that be removed. How does that going to look? Well, if you're removing something from the right, it's going to tip upwards, right? And we're thinking of this as, right, it was in balance. You remove something from this side. A kid got off the seesaw, and then that side pops up. How you go fix it? How do you go back to equilibrium? You have to shift to the right. Grab that. Shift right. And what is that going to cause everything to do? So let me try cleaning all this up, and maybe that'll help. Okay, so let's draw that nice big arrow. It's shifting from the left to the right. Everything over here is going to decrease. Let's see if I can get that out of the way. Okay, so over here, that's where you're coming from. Those are going to decrease. Okay, let's see. It's going to look. There we go. So CO and H2O will decrease. And wherever you're going, the side you're going to, which is in this case the right, the CO2 and H2, that's what's on the right, will increase. So let's go over the steps. Everything starts off in equilibrium. Something happens. Either you're increasing something or decreasing something. You want to go back to equilibrium, and Le Chatelier says it's going to push or shift in a direction to make that happen. Once you know the direction it is shifting in, then you can tell what is increasing and what is decreasing. Right? Okay, so keep working at it. Don't give up. All right, if you have to work a little harder on this topic, that's okay. Don't give up. Keep going.